So we move from ellipses to hyperbolas. You can see that in order to construct a hyperbola, we take and stack two cones tip to tip and then take a vertical cross section, thus creating these opposing dishes, if you will, on either side. What distinguishes the hyperbola is the set of all points in which the difference of distances from two fixed points, being these foci, is constant. Here is that equation that describes that. And if we break down all the pieces of our hyperbola, you'll notice that we've still got this center, which is HK. The axis that carries the vertices is called the transverse axis. The axis that carries the co-vertices, this is a co-vertex, is called the conjugate axis. The length from the center to the vertex is A. The length from the center to the end of the one end of the conjugate axis is B. So in other words, the conjugate axis is 2B in length, the transverse axis is 2A in length. And then we have the distance from the center to the focus, and if I were to take that, we call that C. So in this case, C is going to be longer than either A or B. Therefore, I've got a relationship between A, B, and C of A squared plus B squared equals C squared. Relative to the equations of each of these, if I have a vertical transverse axis, which means my hyperbola is going up and down, y minus k quantity squared over A squared minus x minus h squared over B squared is equal to 1. For a horizontal transverse, in other words, a hyperbola that opens left to right, I have x minus h squared over A squared minus y minus k squared over b squared equals 1. To distinguish once again, we find out which term is actually leading. In other words, which term is positive. If the y term is positive, then that hyperbola goes up and down. If the x term is positive, then that hyperbola goes left and right. We have an equilateral hyperbola if a squared is equal to b squared, by definition. So let's go ahead and sketch a quick graph. Actually, before we do that, let's go back and look at these pictures. We're going to later investigate how we get these asymptotes. And we'll go through that later in the lesson. So if I want to sketch this, I'm going to take and find the center, which is at 3, negative 2. A squared in these is always first, so I have an A equaling 4 and a B equaling 2. And I know since my x term is positive, this is going sideways. So if I want to get a little more accurate, I go over 3, down 2, put a dot for my center. I know this is horizontal, so my A term goes out 4 in each direction. My B term goes up 2 in each direction. And then what I need to do is I need to create a little rectangle. Going through the endpoints of the vertices and the co-vertices. From here, I go through my center and through the vertices of that rectangle and create these asymptotes. And then, using my vertices, and in this case my vertices are on the horizontal axis, I sketch a hyperbola moving left and right and approaching those asymptotes. In this example, you'll notice that I only have one term with the denominator under it, so the first thing I'll do is I'll put a denominator under the second term of 1, and let's identify the center, which is at -1, -7. Mark that as a center. I have an a value of 1 and a b value of 7. We know that a squared plus b squared equals c squared for a hyperbola. Therefore, I have 1 plus 49 equals c squared, and the square root of 50, which is 5√2, is going to be equal to c. So then I'm going to take and just sketch what this looks like real quick. -1, -7, somewhere down here. And then I know that this has to be a vertical hyperbola, so I'll move up 1 and down 1 and left and right 7. Once I'm done with that, I'm going to draw that little rectangle. I don't really have to do this, but showing you how I'd sketch this out. From here I can identify some vertices. My vertices are going to be up and down. So V, in this case, will equal center point, which is -1. And then I move up and down, a total of 1 to get to my two vertices. So in this case, we'll have, instead of -7, we'll have -6. And we'll have -1, -8. Likewise, the foci, I move over -1, but this time we're going to move up and down a c distance. So that's -7 plus or minus 5√2. We need that. Then if I wanted to finish sketching this thing, I could draw my asymptotes through that center point, even though I know I'm not asking to sketch in this case. And then I draw my hyperbola such that it goes through the vertices and approaches the asymptote. Again, making sure it opens up and down. Here's an example similar to the ellipse example where we have a general formula, but we have to get this in our standard formula with perfect squares, which means I'm going to need to complete the square, isolate x terms and y terms, factor out a 9, this time I'm going to have to subtract, pull out a 4, -4 times what is +32, that's a -8, and I bring my constant term over. Take half and square to complete the square, get 25. Take half and square, and get 16. Once again, we have to balance the equation. I haven't added just 25 and 16. In fact, I've actually added 225 from the x's. And in this case, notice since I'm distributing a -4, I'm subtracting 64. So I have 9 times the quantity of x plus 5 squared minus 4 times the quantity of x minus 4 squared is equal to negative 36. Need to get a side equal to 1, so I divide by negative 6 to both sides. Dividing by negative 6 is going to change the sign, so I will take and divide 4 by negative 30, or negative 4 by negative 36, giving me a y minus 4 squared term that's positive over 9. When I divide this 9 by negative 36, I now get a negative term. That's x plus 5 quantity squared over 4. So you'll notice that this hyperbola moves to up and down because the y squared term leads. Therefore, I have a center at negative 5 and 4. I need to find my foci, which means I need to take my a term, which is 3, and my b term, which is 2, and use the relationship of a squared plus b squared equals c squared, giving me a 9 plus 4 equals c squared. Therefore, c is equal to plus or minus root 13. And I'm going to take and move root 13 in an upwards and downwards direction from my center in order to get my focal point. So foci are at negative 5 and 4 plus or minus root 13. Now, given some information, we're going to write the equation of the hyperbola. We know we've got foci at negative 1 and 2 and 5 and 2. So I'm going to sketch those out. Here's negative 1 and 2 up. And let's go over 5 and 2 up. And once again, these are my focal points. Since I know those are my foci, I know this has got to be opening sideways since the foci are within the hyperbola. I also know my center has to be midway between these 2 points. I've got a total of 6. So 3 either way is going to give me my center point, which in this case is going to be 2, 2. Then I have vertices at 4, 2 and 0, 2. So therefore I know my A distance is going to be 2, my C distance is going to be 3, and from there I should be able to almost get done writing this. I need my B value, but I know A squared plus B squared equals C squared. I know I have 9 here, 4 here, plus B squared, therefore B squared is equal to 5. Now I can go ahead and write everything that I need. I start with my center. I know this is opening horizontally, so my x term must lead. So I have x minus 2 squared minus y minus 2 squared is equal to 1. My a term always goes first, so I divide by a squared, and I get an a squared term of 4. My b squared term we've already determined is 5, and now I have the equation written. Let's do the same now, knowing that I have focal distances or foci of 5 and 6 and 5 and negative 12. Let's call this 5, call this 6, and this negative 12. Those are my two foci. I know that since the foci are on a vertical plane, I'm going to have an ellipse, or sorry, a hyperbola that leads with the y squared term and then has an x squared term. And I know that Once again, my center is midway between these 2 points. I have a total of 18 between them now. So 9 is going to get me to my center. And this distance here will be equivalent to C. Next, I'm being told that my transverse axis is 10. So therefore I know that 2A is equal to 10. Therefore A is equal to 5. So I know that if C is equal to 9, A is equal to 5. So 5 up puts me here. 5 down puts me here. These points are my vertices. And if I have my vertices, I can find my co-vertices by getting my B length. I also now have my center, which we said was 5 and negative 3, so I can start writing this in. Plus 3 minus 5 here. I just found my A term, which is supposed to lead, so I have 25. Now all we have to do is find our B term. We know once again that A squared plus B squared equals C squared. I have my C value of 9, so 81 is C squared. A value of 5, so A squared is 25. Plus B squared is going to equal 81. Therefore, my B squared term is 56. And I can just put that term right here. And there's my equation. Let's keep moving. We're now going to take a look at the asymptotes for each of these. Notice that if I have a sideways opening hyperbola and I look at my ellipse and my center is at 0, 0, in order to find the equation of those asymptotes, I do my rise over my run. It just so happens, since I'm going through those rectangles made by the vertices and co-vertices, the slope of that is a rise of B and a run of A. Likewise, if I'm over here and I rise and run in this case, if I have a vertical opening hyperbola, I rise to the vertex, which means I'm rising A and I'm moving over a run of B. So if I want to express these equations, I can say the equations for a centered hyperbola at 0, 0 is plus or minus B over AX and plus or minus A over BX for my centered hyperbola going up and down. If I take and translate that center, I just translate the X and Y points by subtracting H and K to each problem. So let's write some equations for hyperbolas giving information about my asymptotes. I know I have vertices at 0, 2 and 6, 2. So if I want to sketch this out, here's 0, 2 and 6, 2. Once again, these are vertices, so I know my center is dead center between, which is going to put me at 3. Automatically, at this point, I know that I have a horizontal opening hyperbola, which gives me an X leading term, followed by a Y term, equaling 1. We just said we have our center of 3 and 2. I also have my A distance. A in this case is going to be a total of 3. So I know that A squared is equal to 9. And I'm looking for my B squared term. Now I know that since it's a horizontal hyperbola, if I want to look at a slope, I rise and run to get there. In this case, my run value is going to be a total of 3. And it just so happens here that I have a slope of B over A. equaling something that has a 3 in the denominator. Therefore, b's got to equal 2, and b squared then is equal to 4. So now I have my equation for my hyperbola. Won't always necessarily be the case that the term in the numerator is a or b and the term in the denominator is a or b. It could just be a ratio of a to b in a reduced form. And we'll see if one of these comes up next. We're going to take and write the equation of a hyperbola. We have the equation of a hyperbola, and we're going to write the equation of the asymptotes. I know this is horizontal opening. If this is horizontal opening, then my rise over my run is going to be my b over my a term. So I guess it's important that we find both of those. My leading term is always my a term, so a is equal to 9 in this case, b is equal to 3. And I should be able to go ahead and write that actually right now. I've got y minus k equals plus or minus. Once again, we said b over a, so that's 3 over 9, x plus 6. I can simplify that, and I'm fine if you don't put it in slope-intercept form, and just leave it as is. So let's go ahead and do one more example. I've got a hyperbola with foci at 0, 0, and 8, 0. So if I sketch that graph out, I'm looking at this, and here's my 0, 0, that's a foci, and here's my 8, 0, that's my other foci, which means my center is right between those two, which is going to be at 4. And I now know, because I have a distance of 4 from 4 to 8, that my C value is equal to 4. The problem is, in this case, I don't have an A or a B term given to me. I do have a little hint here that I have my asymptotes with a slope of 2 over 1. Now, since I know that my hyperbola is opening sideways, and I must rise and run to get to my asymptotes, the run in this case will be A, and the rise in this case will be B. So I have some y equals B over A x. And in this case, I've got my translation, so I'll add those to it. But the key term here is I have B over A for my slope, which is going to be a ratio of 2 to 1, which is B over A. Again, unlike my previous example, I don't have the exact value for A or the exact value for B, so what I'm going to have to do is make a substitution. I know, since this is a proportion, that 2A is equal to B. And since I know I have a value of C that's equal to 4, and in hyperbolas I know that A squared plus B squared equals C squared, where C is equal to 4, I can make my substitution now, knowing that B is equal to 2A. I can say A squared plus 2A squared equals B squared. Therefore, I have 5A squared is equal to 16, and then A squared equals 16 over 5. Now, if that's the case, and I'm going to write my equation, knowing that this goes sideways here, I have my x term first, so that's x minus 4 quantity squared. A squared term always goes first, so that's over 16 over 5 minus, now my y term is just y minus 0, I'll put the 0 in, over b squared equals 1. Well, I don't have b squared yet, but I do know that 2a is equal to b, and I have an a squared term here, so therefore I know a equals 4 over root 5, and 2a's is equal to b, so 2a equals b, which is equal to 8 over root 5. Therefore, b squared is going to equal 64 over 5. And I could just write that right here and be done. So there's my equation for my hyperbola using a substitution for my a and b's, given that I have an asymptote. That's all we've got. Write your lesson summary and do your My Math Lab, and we'll talk to you tomorrow.